So on number 1, cross multiplying, 3 times 8 is what? 24. Then we multiply this way. We've got to be careful because 6 times x minus 3.
6x minus 18.
Okay, good. Because you got to multiply 6 times x and 6 times negative 3.
Is it okay if they're flipped?
Yes, it's fine.
18, not 13.
Okay, then we're going to add 18 to both sides. So that zeroes out. We get 42 equals 6x divided by 6 on both sides. X equals 7. Okay, number 2, negative 4 times 2 is negative 8. And then x minus 1 times 3 is what?
3x minus 3.
3x minus 3. Because you've got to do 3 times x gives you 3x, and 3 times negative 1 gives you negative 3. And we're going to add 3 to both sides, and this is going to give you negative 5 equals 3x. Zeroed out. Divide both sides by 3 to make this 1 out.
F equals negative 1.6.
Okay, we'll go ahead and say 1.66. Repeating. Okay, number 3, 4 times 7, 28. Okay, x plus 3 times 8.
8x.
Yep, 8x plus 24, so we're going to subtract 24 from both sides. So this zeroes out, we get 4 equals 8x. Divide both sides by 8.
F equals 0.5.
Okay, so x equals 1/2. Okay, so on this next one, we're assuming that these two are similar to each other. And I'm looking for this missing side. So which side matches up to that one on the other one? 25. So this missing side relates to the side that's 25. Okay, so the x relates to the 25 in the same way that the 12 relates to the 15. Okay? So from here, we're just going to cross multiply. 25 times 12 is what? 300. And x times 15 is 15x. Divide both sides by 15. Okay. This next one. So this is the side I'm looking for, and it matches up to the 10. Now, that side is going to relate to the 10 in the same way that this side relates to this side. Now, on this, it's really easy to see. How does this side relate to this side?
They're both in halves.
It's half. This is half of this. So if these are similar, this is going to relate to this in the same way. It's going to be half. So this is going to be 5. Okay? But let's go ahead and set it up and work it out just to see that. So I'm going to say the 10 is to the x as the 8 is to the 4. Cross multiply, we get 8x equals 40. Divide both sides by 8, and x equals 5. Okay. Now, on this last one down here. So we're going to cross multiply. 8 times 6 is what? 48. Okay, what is x times x plus 3?
X squared plus 3x.
X squared plus 3x. Now I've got an x squared here. Are there any other x squareds that I'm going to be able to combine with this that's going to cancel it out or anything? Nope. Okay, I've got a 3x here. Are there any other x's anywhere that I'm going to be able to combine with this to maybe cancel that out?
No.
Nope. Okay, good. So this is going to be like one of those things that we were doing. You know, we've done with several different situations where this comes up. Okay, so what I'm going to do is I'm just going to flip this around first. X squared plus 3x equals 48. And then what do we do from there?
Move 48. Subtract 48.
Okay, so we just subtract the 48 from both sides, set it equal to 0. And then that way, whenever I graph this and where I see where these where the graph hits the x at 0, then I'll know I've got my solutions. I'll know what the value of the x's are. So it's a little trick to do that. I mean, a very well-known trick. It's just a good way to do it. So what we're going to do now is graph this. So go ahead and type this into the graph on your calculator. And we're going to see where it crosses the x-axis. Okay. So when we type this in, x squared, what was it? Plus
3x minus 48.
3x minus.
We always see this.
Okay, so it crosses here, crosses here. Now, you can see it does not cross at whole numbers, so how are we going to find out where that's at?
Menu 6-1.
Okay, we're going to do our zeros. Menu 6-1. Okay, so I'm going to click there, and it shows me that it crosses on that side at negative 8.59, so that's one value of x to make that. You could do Control T, but I just like this way better. And then 5.59 is the other one. So negative 8.59 is one solution, and 5.59 is another solution. Okay, so negative 8.59 and 5.59. Okay, so x equals, what do we say, negative 8.59, and x equals 5.59. Okay, so on the back of where your warm-up is, and look at the notes for the stuff we're doing today. Now, the stuff we're doing today really is the same math that we've been doing. It's just that it's coming from different situations. Okay, so the first one here is the triangle proportionality theorem. Okay, it says if a line is parallel to a side of a triangle. So remember we talked about this. Whenever you see that extra set of arrowheads, that's indicating that those two lines are parallel. So if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So like what they say right here, BX, so BX, that's this, relates to XA in the same way that BY relates to YC. Okay, so let's look here at number 1, and we can see right here, parallel lines. Okay, well, first of all, we're looking for RQ, okay? We're looking for RQ, this from here to here. Now, there's several ways to look at this and think about this, okay? The way we're going to do it is, all right, the 12 relates to this side in the same way that the 6 relates to this side. And so we're just going to work this out like we've been doing, just cross multiplying 6x equals 84, divide both sides by 6, x equals 14. X equals 14. Now, I want you to see this because since it splits this proportionally, the proportionality works in several directions, really. Because this is another way to think about it. It also works like this, that this relates to this in the same way that this relates to this. Because if you think about this, how does the 6 relate to the 12? It's exactly half of it. So this is going to be exactly half of this. 7 is half of what? Of 14. So there's multiple ways to set this up. Because also if we set it up like that, if I said 12 is to 6 as x is to 7, okay, I set it up differently than I did over here, but if you think about it, over here the 12 got multiplied by what? 7. By the 7. What's going to happen over here? 12 is going to get multiplied by the 7. The x got multiplied by the 6. It's going to end up working out the exact same way. Okay, So on number 2, we're looking for JN right here. Okay, so the 20 relates to the 16 in the same way that the 38 relates to the X. Alrighty, so 16 times 38 is what? 608. Okay, and 20 times X obviously is 20X, divide both sides by 20. And it does give a decimal, 30.4. Okay, so this is just one theorem, one property that's just true of triangles when that happens. So it's just another occasion for us to stumble across using proportions here. Okay, then here's another place where it shows up where this works out is the AngleBisector Theorem. An angle bisector of a triangle divides the opposite sides into two segments whose lengths are proportional to the lengths of the two other sides. Okay, so it's been a while since we've talked about this, but what does angle bisector mean? What does bisect mean? Cuts it exactly in half. So an angle bisector cuts an angle exactly in half. So like that's exactly what's going on right here, that AY is the angle bisector for that, in that situation. And so that angle bisector splits that proportionally. Okay? And so that's what's happening down here on number 4. This DF is the angle bisector in this situation. You know it's the angle bisector because that angle and that angle are congruent. That's what a bisector does, is makes two congruent pieces. Okay, so there's definitely more than one way to set this up and definitely multiple ways to look at it. I'm just going to do it like this. So the x relates to the 8 in the same way that the x plus 2 relates to the 12. Whoops, sorry. Okay.
So if you were to do like, I'm confused a little bit, why would you? Never mind.
Okay. There's, like I said, there's definitely multiple ways to do this. If you were to say like x is to x plus 2 as 8 is to 12,
Would that work?
you're still going to be, because it's still multiplying the same things.
Okay.
When you're doing these, like I said, there's multiple ways to do it. You just have to be consistent in the way you do it. And what I mean by that is this, is if I were to say x is to 8, I could not say then that as 12 is to x plus 2. See how I'm going in opposite directions? You can't do that. That would give you the wrong answer if you did it that way. You have to be consistent in the way you do it. So since I started from up there going to there, I've got to do it the same way here. Okay, so let's cross multiply. So what is 8 times x plus 2?
8x plus 16.
8x plus 16, and then what's x times 12?
12x.
It's 12x. All right, let's get our x's together. Zeros out, 16 equals 4x. Divide both sides by 4. So x equals 4. Now on this one, it's asking for more than just x. We need to know what x is, but it's asking for the length of these two segments. So EF, how long is EF going to be?
4.
It's 4 because it's just x. So EF is 4. And then if x is 4, how long is FG? 4 plus 2 is 6. Okay, on this last one, RT is the angle bisector. So it splits this proportionally. So on this one, I'm going to say like 40 is to 16 as 3y is to y plus 3. All right, so what's 16 times 3y?
120? No, 48, right?
Yep, 48y. And then what's 40 times y plus 3?
48y plus 120.
Plus 120. Yep. Okay, then we just want to get our y's together first. So subtract 40y from both sides. This gives us 8y equals 120. Divide both sides by 8. So y equals 15. Now in this one we got one more step because we want to know how long both of those segments are. So if I take this 15 and plug in here, what's 3 times 15?
45.
So RV is 45. And then if I take 15 and plug it in here, what's 15 plus 3? Is 18 for TV.